Okay guys, I hope this lesson today is going to be quick and easy. Basically we're going to just learn about how to change vectors from one form to another. So we're going to focus on two tasks here. You're going to be given vectors that have an initial point, end point, and we're going to convert that to component form, and then we're going to convert component form to linear combination form. And there's really nothing difficult about this. The only thing that might be difficult is understanding why you would do this in the first place. You might wonder why there's different forms for the same thing in math. It happens a lot. And sometimes there's dumb reasons, sometimes there's good reasons, sometimes there's no good reason. This one's very interesting. The other one, it's so easy, so simple, you're not even going to care why you would do it. It's just like, duh, do it. So the component form to linear combination, or what we called IJ yesterday, or the previous lesson, I guess that was 2 days ago. That's not going to be so bad. But the initial endpoint, again, that's not bad either. It's not difficult. It's just why on earth would you do that? Okay, so in problem 2 here, we're given a vector CD. C is the initial point, D is the terminal point. We know it's terminal because the arrowhead is over the D, so it's from here to here. And so C is -8, 3, D is -7, 5, and we need to turn that into a component vector. Remember, a component vector has its initial side at the origin right here. So basically, we're going to take this blue arrow and kind of slide it over here so it goes kind of like this. But we need to know what are the actual XY points of the endpoint of that arrow. So what we're essentially doing in problem 1 through 8 is learning how to take the arrow, the vector that's given, and slide it so that its endpoint is here and then the terminal point is wherever it might lay. But we can't just say wherever it might lay. We need to calculate the exact point. So how do you take a physical shape like that and slide it over? Might seemed mind-boggling, like how do you do that? It's really not. It's man, what do I say? You do, I'm sorry, I'm about to write that backwards. Watch me screw it up anyway. Terminal point minus initial point. And that does it. So the terminal point is D, so -7, 5, and we're going to minus -8, 3. So yeah, it's just a subtraction problem. -7 minus -8 is, let's see, minus minus turns to plus, so that's 1, and 5 minus 3 is 2. So 1, 2 is our component vector. So you don't have to draw on this assignment. I'm going to be drawing in my notes, but you don't have to. All you have to do is find the answer that I circled right here. So it's just a matter of subtracting two things. And if you look at this problem right here, it's kind of like what we learned in matrices. How do you subtract matrices? These aren't technically matrices, but if it was 7, 5, and -8, 3, and you subtracted them, it'd be pretty much the same thing. So the math we're doing is kind of like what we just got done doing. But anyway, this blue arrow, again, component vectors always have the origin as their initial point. Go over 1, up 2, there's the terminal point right there. So we just slid this arrow right there, and there it is. I'm going to draw that just a little bit better. So if we check the answer, it should say 1, 2, right there. And again, you don't have to provide the drawing if you don't want to. I'm just going to, well, yeah, I don't know. Okay, so change RS. Oh, you know what I forgot? Why would you do this? Okay, this is kind of a, I don't know, I could ramble and I don't want to do that. I want to keep this video concise. But basically, this vector represents something in theory. It could be like the motion of, like a comet in space. It could be a little toy car sitting on a tabletop. It has a starting point and then it rolls and then it has an end point. And if you want to talk about the mathematics of the velocity or the motion, the force that it's exerted by it, or all these different things can be represented by vectors. And when you start doing math on these, especially when you have more vectors at once that kind of act together and do things together, the numbers get really hairy. And so what happens is, if you had a table, like let's say this graph paper is the table, some random point on the table is considered the origin and the car is way over here and it rolls to there. Well, if the car were at the origin and rolled over here, all the exact same physics and everything would have happened. It'd just been a lot easier to work with if, sorry about that, a lot easier to work with if it were at the origin, because half of the numbers you're dealing with are zeros, and it's super easy to do math with zeros, multiplying and adding and all sorts of stuff. So basically, if any vector is refocused at the origin, then doing math with that vector works out to be a lot easier. So there are certainly instances where the exact location where something starts and ends is important. You wouldn't take that away in those situations. But in others, when you just want to do math on forces or velocities or gravity or lots of these different things that can be represented by vectors, it's just easier to do if one of the points is 0, 0. So that's why you do this in the first place. It goes back to physics and other applications of vectors. Okay, so let's find the component form of RS. So S is the terminal side, so it's 7, 2 minus R, the initial side, negative 8, 9. 7 minus 8 is 15. 2 minus 9 is negative 7. Put it in these brackets instead of parentheses, and that's our answer. So I really can't draw this. 15 negative 7 would be way over here somewhere, and my vector would look kind of like that. Look, I said I wasn't going to draw it, and I drew it anyway. So that's horrible. That's bad, but you get the idea. That's how that works. Let me go down and check number 4, see if it's 15, negative 7, and there it is. Oops. There it is. Okay, so number 6. CD. D is the terminal side, so we're going to go 5, negative 1. Minus negative 5, negative 4. 5 minus minus 5, minus minus turns to plus, so that's 10. Negative 1 minus minus 4 turns to plus. Negative 1 plus 4 is 3. Oops, and I want that in these pointy brackets, not parentheses. And so there's the answer. And again, if you were to draw this, 10, 3 would be right about there. I guess it'd look kind of like that. So yeah, that blue arrow shifts up and to the right like that. Number 6, let's see. I feel a sneeze coming on. Fair warning. Okay, I fought it down. Oh, there was another one. Oh, that's the most horrible thing you're going to ever have to hear in your headphones on YouTube. Me holding back a sneeze. I am so sorry about that. But I'm not about to stop the lesson and redo the whole thing. Sorry. Sorry about your luck. All right, number 8. RS, S is the terminal side. Let's find the component vector. So negative 7, negative 6, minus 4, negative 9. Oops, make that better. Parenthesis. Negative 7 minus 4 is negative 11. Pointy bracket. Negative 6 minus minus 9 is plus, so that's 3. Negative 11. 3 would be somewhere up here, so we get an arrow that looks like this, which looks about right. Oops, gotta make that parenthesis on the 3, one of these bracket things again. So there's our component vector, negative 11, 3. There it is. Okay, so there's 1 through 8. The math you do is very, very simple. Again, if you need a formula, there it is. Terminal point minus initial point. I think I've been saying terminal side and initial side, because when we graph angles in trig, that's what you call them. I'm sorry about that. Terminal point minus initial point. And then you put your answer in those pointy brackets. Okay, now for the rest of this, super easy. Why this ij notation, or linear combination as it's called here in the directions, why does that exist? Oh, to be quite honest with you, I don't remember. I just know it's so easy. So we've got negative 3 comma 20. This is a component vector. If I want to write this as a linear combination, it's negative 3i plus 20j, and that's it. So that's just a different way to write a vector. The different notations have uses in different maths, different types of math, and what you're using it for, I guess. So number 12, simply negative 33i minus 41j. And again, that's it. See number 12. There it is. So yes, this assignment should be pretty quick and easy for you. I bet some of you are going to press stop and get right to it right now. Number 14, anyway, negative 26i plus 45j. There that is. Number 16 would be 2i minus 2j. Check those real quick. Right there, right there. So that's all there is to it. You just put the first number, the x value in front of I, the second number, the y value in front of j, so it looks like xi plus yj, and that's how it's done. You're not doing you're not calculating anything, you're not working anything out, you're just changing it from component form to this linear combination form. All right, so I could probably summarize and recap and re-explain, but I think you got it. It's not the hardest thing you've ever done. If you have questions or issues, please contact me through comments or email. Otherwise, have a great day.